All right. Computing the sample correlation coefficient and the coefficients for the least squares regression line. So these ones here, you're going to have the problem two different ways. Either you're going to calculate the sample correlation coefficient, which is R, or you're going to do the coefficients for the least square regression line, which means you'll be writing the equation y hat equals and figuring out what the equation is. So on this first one here, it says Sir Francis Galton in the late 1800s was first to introduce the statistical concept of regression and correlation. He studied the relationships between pairs of variables such as the size of the parents and the size of their offspring. Data similar to that which he studied are given below, with the variable x denoting the height in centimeters of a human father and the variable y denoting the height at maturity in centimeters of the father's oldest son. The data are given in the tabular form and also displayed in figure 1 as a scatter plot. Also given are the products of the heights of the fathers and the heights of the sons for each of the 16 pairs. These products written in column labeled XY may aid in your calculation. They will in your calculation because you need to have them. So they're not going to make you take the 175.3 times the 176.7. They already did that for you. However, you do need some data from this table, so we are going to use our calculator in order to figure out that data. So again, we're going to just use our statistics, and what we have to do is calculate the mean and standard deviation, etc., of the first column and of the second column. Now you can either put all your values into list 1 and then the other set of values into list 2, or you can put them in list 1, calculate your statistics, then go back and put the other one in list 1, calculate your statistics, and go from there. So, if you again hit Stat, 1 for edit, and cursor up and clear out whatever's in there, hit Enter. If you list all of the heights of the father in list 1, you could also do the sons in list 2 if you wanted to, but then you'd have to calculate your statistics on list 2. Otherwise, like I said, just put all of these in list 1, calculate your statistics, then we'll do all of those in list 1 a second time, do the second ones, calculate your statistics, and we'll go from there. So, go ahead, pause the recording for just a bit while you get your data in there and calculate on there your mean and your standard deviation, the S of x. So you're going to want the x bar for the first list, the S of x for the first list, and then we're going to do the second list. So x bar for the second list and S of x for the second list. I've already done the calculations, but go ahead, pause the video, put them in there, figure out your data, and when you're ready, you can double check with what I got here. So x bar of 1, when I did the first list, I'm going to say that was list 1. Almost looks like list 1. I got a mean of 180.5. And my standard deviation, my S of x, was 13.7125. In this case, N1, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I have 16 numbers. When I did my second list, you can either put them in list 2 or just re-put them in list 1 and calculate your statistics again. Doing the calculations on list 2, my mean of list 2 was 181.544 if I round that off. We needed to carry, to 4 decimal places. I better go to 4 decimal places. Carry my intermediate calculations to 4 decimal places, it says on this one. So 181.5438. My standard deviation, 8.9416. So again, can't get that to right. 8.9416. We're just going to use the stat, do 1 to edit, and then you're going to do stat, and you're going to calculate number 1 for 1 variable statistics on your list. So find that information. We'll need it in our formula. The other thing you need to do in order to figure out the answer to this problem is you need to find the sum of your XY column. So here's my symbol for sum. It looks something like that, the sum of XY. So you'll want to go through and add all the numbers up that are in your XY column. Again, go ahead and just pause the video, add them all up. I already have done it, so I'm not going to wait a whole bunch of time for you to do your adding. But if you add all those numbers in the XY column, finding the sum of this column, you should come up with 525,817.49. So 525,817.49. So adding all the sum here gets the sum of that. So once I have that information, I can then use the formula to find what my R value, my sample correlation coefficient is. What this number stands for is when I do my line of best fit, how close is that data to my line? If it was exactly on my line, I would get an R value of 1. You can see here I'm not exactly on the line, so my R value is going to be probably somewhere close to 1, but not going to be exactly 1. We're going to find out what it is. So the formula says to do the sum of XY, which is this number right here that we just found, minus n times the mean of x1 and the mean of x2 over n minus 1 times the standard deviation of x1 and the standard deviation of x2. So the n's for both of these should both be 16 because I have the same numbers, father and sons, they both were 16. So I'm going to plug that into my formula, do my calculations. So I'm going to take 525,817.49 minus n was 16 times the 180.5 times, I'll sneak it down there, the 181.5438. I'm writing it sideways. So on the top of my fraction, I have the sum of xy minus n, which was 16, times the mean of my first set of data, which was 180.5, times the mean of my second set of data, which was 181.5438. That all is on the top of my fraction that I didn't leave myself enough room to write. Then I'm going to do n minus 1. So I'm going to do 16 minus 1 times the standard deviation of the first, which is the 13.7125, times the standard deviation of the second, which is the 8.9416. You can almost read all of that. I don't have any spots that are any whiter to write on. So, again, you're going to punch this into your calculator. The Alex calculator is probably easier to punch it into. Or find the top number, then find the bottom number, and then go ahead and just divide your two numbers. But the sum of this column XY, then the number of items we have, the mean of the first, the mean of the second, and that's your list 1 and your list 2. Then n minus 1, the standard deviation of the first and the standard deviation of the second. When you work that out, you are going to go to 3 decimal places. Again, I may have rounded off a little differently than you, but you should be close to 0.3 0.826. The closer you are to 1, the closer you are to having all those dots line up in a nice straight line. You can see that they're not quite on the line, but they are pretty close in my positive direction. So 0.826 is the value of R. So put list 1 in your calculator, find your statistics. List 2 in your calculator, find your statistics. Add up all the values in the XY column, and then you can plug them into your formula. All right. Number 11. Number 11 says an electric utility wishes to examine the relationship between temperature and electricity use in its service region during the summer months. The bivariate data below give the maximum temperature, denoted by X in degrees Fahrenheit, and the electricity use, denoted by Y in thousands of kilowatt hours, for a random sample of 15 summer days. The data are shown in figure 1 in the scatter plot. The value of the sample correlation coefficient is approximately 0.707. So R is 0.707. If I would put my line of best fit in there, you can see my data scattered out farther from my line, so it's farther from 1. Answer the following. Carry your intermediate computations to at least 4 decimal places and round your answers as specified below. So first of all, they're going to have us find the value of the slope for our least squares regression line. So again, we're going to do our regression line y hat equals, and first of all, we're going to find the slope of that value, which is the number in front of the x. So in order to find the slope of that value, they're going to tell you that we're going to do y hat equals b sub 1x plus b sub 0. The b sub 1 is the value of your slope. So the formula to find that value for b sub 1 is to do r times the standard deviation of your x column over the standard deviation. Oops, I better do that the right way. Standard deviation of your y column is on top. Standard deviation of your y column over your standard deviation of your x column. So again, you're going to have to use your graphing calculator. Do your x column and find your statistics. Do your y column and find your statistics. Go ahead, pause the video while you type those into your calculator in order to find your data. I've already calculated it out. So again, I'm going to have my list 1, which I'm going to call my x bar for my mean, my list 2, my y column for my mean. And so separately, I put in my data for list 1, calculated the statistics on that list. My mean was 85.2800, going to 4 decimal places. My standard deviation, 9.9369. And if I counted here, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 numbers on my list, so n is 15. Then I did my data in my second column, my y column. If I do my data in my y column, I'm going to have a mean of 314.1933. I'm going to have a standard deviation of 39.8793. So put those in your calculator in the stat function in your list. Calculate that out. Again, you do stat and 1 to edit to put your list in, and then stat and go to calc and 1 for the 1 variable statistics. Now that I have that data, I can use my formula to find my B1 value. B1 is equal to the R value, 0.707, times my standard deviation from my Y, 39.8793 divided by the standard deviation of my x, 9.9369. Go ahead, punch that into the Alex calculator, 0.707 times 39.8793 divided by 9.9369. If you do that calculation, we are rounding this one to 2 decimal places. You should come up with 2.84. 2.84. That would be the slope of your linear regression line. So y hat would equal 2.84x. Now you're going to find the value for the b sub 0. The b sub 0 is your y-intercept of that line. It tells us the formula to find b sub 0, I'm going to write it over here, is the mean of y minus b1, which is your slope, times the mean of x. So in order to calculate that out, I'm going to write it down here, b sub 0 equals the mean of y, 314.1933, minus the b1 value, which is your 2.84, times, I'll put it underneath there, but it's really behind there, the mean of x, which is the 85.2800. I'm going to write that over here again. B sub 0 equals 314.1933 minus 2.84 times 85.2800. There, now I got it all the way across the page so you can see how that should be typed in. I'm going to go ahead again. You could put that in your regular calculator or use your Alex calculator. But the mean of y minus the 2.84, which was your slope, times the mean of x. When you put that into your calculator, you should get 72.00, 72.00. That means that on the end of my equation, I would have that, and that would be my line of best fit. Or the equation of my line of best fit looks something like that. So 2 parts to that. You're going to find the slope by taking r times the standard deviation of y divided by the standard deviation of x. And then you're going to find your y-intercept by taking the mean of y minus the slope times the mean of x. And last one on this page. Let's see if I can get the whole question there. It says, the well-known psychologist Dr. Elbot has established what he calls his General Anxiety Scale, GAS. The GAS, which is a scale from 0 to 10, measures the general anxiety of an individual, with higher GAS scores corresponding to more anxiety. Dr. Elbot's assessment of anxiety is based on a variety of measurements, both physiological and psychological. We're interested in making predictions about the individual's sleep behavior based on their GAS scores. The bivariate data below gives the GAS score denoted by X, and the number of hours of sleep last night denoted by Y for each of the 15 adults participating in the study. A scatter plot of my data is shown. So in this case, if I would put my line of best fit in there, it would look something sort of like that. So this one, although it tells you to find the y-intercept first and the sample correlation coefficient, in order to find the y-intercept, you also have to find the slope because that was part of my equation. So I am going to go ahead and find both the b1 so that I can find the b0. So even though it just asks for the y-intercept, you have to find the slope and then find the y-intercept. So again, on this one, you will use your calculator, the stat function, put list 1 in and find your statistics, put list 2 and find your statistics. Again, just pause the video while you're putting that data in and finding those statistics. When you're done, turn it back on. I have already calculated them. So stat function, one for edit to put your list in, and then stat, calc, and do the one variable statistics. So on my list one, my x values, x bar, my mean came out to be 5.2133. My standard deviation for that first list, 2.7640. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So n is 15. When I did my second list, the y list, the mean of y came out to be 7.0267. And the standard deviation of y, 1.0606. So, if we don't have to find the slope, if I would have read the problem. The least square regression line for this data has a slope. They gave us the slope, so we don't have to find the slope. So we know that in our equation, the B1 value is your slope, is negative 0.27. So they did give us that. We don't have to calculate it out. So since we do know what the slope is, we can then go to the formula to find out what B0 is. B0, we said, was the mean of y minus the slope, which is B1, times the mean of x. So in this case, my mean of y, 7.0267. I'm going to subtract the slope. In this case, my slope is negative. So I'm going to subtract a negative 0.27 times my mean of x, 5.2133. So be careful on that. There's a subtraction in the formula, and then our slope is negative. So I'm going to have minus and then a negative 0.27 times 5.2133. So again, just put that in your calculator, 7.0267 minus parentheses negative 0.27 parentheses 5.2133, and rounding that off to the nearest hundredth or to 2 decimal places, we would have 8.43. Which means my regression equation would have been y hat equals negative 0.27x. My slope is negative with a y-intercept of positive 8.43. You can see I kind of drew my line in there. It's not quite at 8.43, but it's kind of close to that. It's between the 8 and the 9 anyway. So when I drew my line in there, it was kind of close. On the second one, we want to find that sample correlation coefficient. And so in order to find your sample correlation coefficient, we're using the formula that R is equal to B1 times the standard deviation of X divided by the standard deviation of Y. So in this case then, R is going to equal B1. B1 is my slope that they gave me, negative 0.27. This one formula has the standard deviation of X on the top, 2.7640. And it has standard deviation of Y on the bottom, 1.0606. And so, a lot easier to find your R value if you know that information from your equation instead of having to use that gigantic formula we used on the first problem. We're just going to punch that into our calculator. So negative 0.27 times 2.7640 over 1.0606. Rounding off to 3 decimal places on this one, we should get negative 0.704. And again, depending on rounding, it may be different, but I did carry mine to 4 decimal places like they specified, so I should be pretty close. All right, that is the end of homework 20.